Okay, guys, sorry I got cut off on the last video. This is the second part of the Unit 9 Honors Review Packet. And what I was saying at the end of the last video is if we want to find the area of this shaded region here, the easiest thing to do is find the area of the sector. Now remember, the sector is like the piece of pie. So this whole thing here included the shaded part. And then we're going to subtract out the area of the triangle, and that will leave us with just this shaded portion here. So we're going to start by finding the area of the whole sector, the whole piece of pie. Remember, it's our angle over 360 times pi r squared. So 5/4 squared, okay? So this is really 1/6 of 16 pi. And for right now, I'm just going to leave it as a fraction. So 16 over 6 is the same as 8 over 3. That's the area of my whole sector. So now let's do the area of the triangle. Now we're going to have an equilateral triangle. The reason I know that have to be the same, which means that these angles have to be the same. If I have 120 left over, that means they each have to be 60. Okay, so I have an equilateral triangle, which means if I cut it in half, I'm going to have a 30, 60, 90 triangle. So if this has a length of 4, this whole thing was 4, so this is going to be 2. You can either use the Pythagorean theorem, or based on our special right triangles unit, we know that this is going to be 2√3. So if I want to find the area of the triangle, it's 1/2 base times height. The whole base is 4. The height is 2√3. And that's going to leave me with, so 1/2 of 4 is 2. 2 times 2 is 4, 4√3. So my final answer is going to be 8/3 pi minus 4√3. And if I turn that into a decimal, now you could leave it just like that. You would get 1.450 units squared. So either that or that. So let's hope that's right. I hope it matches the key we did before. Okay, find the area of the shaded region. Same thing here. We're going to find the area of the circle. If we subtract out the area of the square, that will give us our total area. Well, the area of the circle is pi r squared. Okay. Now the area of the square. Well, if you think about it, if this is a square, these are all going to be 90 degrees in here. These 90-degree angles are going to get cut in half, right? This is going to be 5. This is going to be 5. That's the radius of the circle. And if I use my special right triangle rules, that's going to be 5√2. You can also use the Pythagorean theorem to solve for this side here. So the area of the square is base times height. It's 25 times 2. So my total area is the area of the circle minus the area of the square. Okay, let's keep moving on. Okay, the first thing I'm always going to do is determine what kind of problem it is. So this is an angle and arc problem. Specifically, it's an on problem. Okay. You will notice that we were given these two parts of the arc. Okay. Those are going to go with this inscribed angle, or this angle that is on the circle. Okay. Remember, angle, if it's on, is half of the arc. So this angle here is half of this whole thing, which is 170. So my answer is going to be 85. Oh, sorry, not done yet. My bad, my bad, my bad. Sorry, x is 85. We're trying to solve for this. Well, we know that angles that are across from each other in the quadrilateral that's inscribed or inside of a circle, they're supplementary. So my unknown angle is going to be 95. Number 17, this is an angle and arc problem, and you'll notice the vertex is outside the circle. So my formula is that angle equals 1/2 arc minus arc. Okay. We don't know what this is, so we can call that x. X goes from here to here. The rest of this is 360 minus whatever x was. So my angle, 68, is 1/2 the big arc, which was 360 minus x, minus the smaller arc. So that's 1/2 of 360 minus 2x. 1/2 of 360 is 180. 1/2 of 2 is 1. Okay. I'm going to add x to this side, subtract 68 on this side, and I get 112. Okay. I'll let you guys do 18 by yourself. You can do 19 by yourself. Number 20 is a lot trickier than I realized, but let me at least set it up for you guys. We know that opposite angles have to add up to 180. So 5y plus 25 plus 5x plus 15 equals 180. So these two things here. Okay. Similarly, 5x plus 7y plus 10 has to add up to 180. Okay. I need to solve for x and y, which is hard because I have both variables in both equations. So what I'm going to do up here is divide everything by 5. If I divide this by 5, I get y. If I divide this by 5, I get 5. If I x, divide that by 5, I get 3. Divide that by 5, I get 36. And you'll notice that'll end up giving me y plus 8 plus x equals, so I'm going to subtract this 8 onto the other side. That's going to give me 28. So I could say that y equals 28 minus x. And now this can go in for y, and you can solve. Let me just check that really fast. Yeah, I think that looks pretty good. So I'll let you guys finish that by yourself now that I set that up for you. 21's pretty straightforward. Let's move on to 22. You'll notice here is my on problem. If I double an on, that'll give me this arc. These two have to add up to 180 because this thing here is a diameter. Okay. So if I subtract 66 on both sides, I end up getting 114. Okay. Number 23. Here's my first part of the arc. Here's my second part. This is an out problem. So my angle is 1/2 arc minus arc. My angle is 3x plus 8. My arcs are 16x plus 4 and 108. Half of 16x is 8x. Half of 4 is 2. Half of 108, see that should be a minus side, is 54. Okay. I'm going to subtract 3x onto this side. I'm going to add 52 to this side, and that gives me x equals 12. I think you guys can figure that one out. It's very similar to this problem. Okay, so we'll move on to the next page. Remember, there's a key on Blackboard too, so you can use that to help you. I am going to skip around. Let's see. I think these are a little more straightforward, so I'm going to let you guys work on these by yourself. Let's do number 28 together. This is going to be a PP problem because everything's on the inside, so I'm going to do part times part of this first line equals part times part of the other. If I distribute, so I'm going to FOIL, I'm going to get x squared minus 4x minus 3x plus 12 equals 72. So x squared minus 7x. I'm going to subtract the 72 on this side. Okay. If I'm going to factor, I need a 0 on one side. Okay, so now I'm going to look for two numbers that multiply to negative 60, but add to negative 7. Okay. Negative 12 plus 5 is negative 7. Negative 12 times 5 is negative 60. So the two answers that make this function work, so if I plug in a positive 12 here, this becomes 0, so 0. Negative 5, it makes that one 0, but notice I can't plug in a negative 5 because I get negative 8 and negative 9, so that answer is no good. I believe we did 29 in a handful of our classes, so I'm going to skip that one for now. Let's do number 30. Okay. This goes outside, so this is a whoa problem. So we're going to do whole. So this whole thing here is 2x plus 1 plus 10. So 2x plus 1 plus 10, 2x plus 11. The outer portion is 10. This whole thing is 2x plus 5 plus 9, so 2x plus 14. The outer portion is 9. So that's going to give me 20x plus 110, and then 18x plus 126. I'm going to subtract 18x on this side. I'm going to subtract 110 on that side. And I get x equals 8. Okay, let's do number 31. I think we might call it a day. 31. This is a whoa problem because we go outside the circle. So this whole thing here is 40. The outer portion is the whole thing. That's also 40. This whole thing is 32 plus 3x plus 6 because you're driving. You're saying I'm doing this much, and then I'm also doing this much, so we add them together. So that whole thing is 3x plus 38. The outer portion is just 32. So this is numerically heavy, but we can do this. 40 times 40 is 1600. 3x times 32 is 96x. 38 times 32 is 1216. I'm going to subtract 16 on both sides, and I get 384 equals 96x. And I'm going to divide by 96, and I get x equals 4. Okay? So I believe we had a couple of these harder ones in class, so I'm going to skip those for now, but I hope this gives you guys kind of that just like helpful review that you need. Remember to memorize your formulas. Here's a quick recap of the formulas you should know. You should know the equation of a circle. Okay. You should know that we have 2 tangent rules. We've got party hat. And we have the radius meets a tangent at 90 degrees. Okay. We have some chord rules. Then if we're dealing with arcs and angles, we have on, in, out, half, plus, minus. Okay. If we're dealing with segments, we have PP equals PP, so part times part equals part times part, and whole times outer equals whole times outer. Okay. Got a little bit more. Let's see if I can find a place to squeeze it in. Okay, we've got arc length. That's a fraction of your circumference. And then we also have sector area, which is a fraction of your area. Okay, so we've got arc length, we've got sector area, we've got the equation of a circle, we've got some tangent rules, we've got some arc and angle rules, and we have some segment rules. Okay, good luck, guys.